we are going to be moving on to our second speed talk of the day from Tomi Piriyev, and he is going to be talking about the Loko offline GPS tracker.
Okay, and thank you for inviting me. My name is Tomi Piriyev. I'm co-founder at Knoedler, and today I will talk about the Loko, which is an ultra-low power offline GPS tracker. It's an open source project, and we believe that it has huge potential in wildlife research. So let's have a look at the challenges in wildlife research and the areas. There are mostly the remote areas. There is no GSM or internet coverages. Devices with the short battery life. In remote areas, it's not easy to change the battery, and the costs are high, difficult to maintenance, and difficult to operate. And that's why we developed Loko, which is a super small, not the smallest GPS tracker. It weighs only 14 grams. And it is you can compare the size with the iPhone on the picture. So it is so tiny, tiny GPS tracker. And it has peer-to-peer communication with the receiver on the left side. And it can also connect to the LoRaWAN network if the area has a LoRaWAN coverages. And with the peer-to-peer communication, it can make over 20-kilometer range. And battery life, it can go up to a year. On the next slide, I will talk about battery life. And it's an open source, completely open source project. And it has also USB Type-C ports for the recharging, for configuration, and also developers can customize the firmware inside. And how it works, it's the small device is the GPS tracker. So we attach on animals or objects which we want to track. It transmits its own unique ID, latitude, longitude, altitude, velocity, and the battery data to the receiver on the right side over LoRa radio, and the receiver sends this data to the smartphone via Bluetooth. And it has a Loko app, and it shows this data on map. It also uses offline maps. That there's no requirement for the internet network. And about the battery life, so to keep the operation for a longer time, so we made the battery operating a little bit different logic. So we set the transmit interval. So let's say user want to get the data at each 60 seconds. So device goes to deep sleep mode 60 seconds, then wakes up, gets the new GPS data, transmits it, and then go back to deep sleep again. And then 60 seconds waits, and then we'll repeat this cycle. In deep sleep mode, it consumes about 9 microamp. It is very low power, but on wake-up period, it consumes about 36 milliamp. It is a very high power actually for such a small device, and that's why we want to keep this wake-up period shorter. And on open area, it takes about 9 seconds. But if the area is not open, the GPS, it takes longer time to get a new GPS data. And that's why battery life, if the area is not open, battery life will decrease. If the area is open, so battery life will be longer. And it has easy to configuration tool, and user can configure its unique ID, pairing ID, frequency. User can set the frequency for its location. And interval, user can set the transmit interval, what he wants to get, and also can activate the velocity and altitude information if he wants. Also, it can set for balloon mode, which enables the GPS to operate 80 kilometer over the sea level. And user can also activate the encryption if the data is sensitive. And if I highlight technical highlights, it is completely open source hardware and software, and we believe that this will help to rapidly customize the software or hardware for different research needs. Frequency covers global coverages, and it has encryption for AEC 128 for sensitive data. And also with the one receiver can track multiple GPS trackers simultaneously. And application areas are like animal tracking, anti-poaching, patrol monitoring, equipment safety, and many others applications. And after getting a lot of feedbacks, so we right now we are working on a collar with built-in Loko for the cat or dog tracking, and also for in a shape of necklace for human tracking. This is mainly users ask for the tracking people with the Down syndrome, and also 5-gram version of the Loko for the bird tracking specifically. And also we are developing solar powered receiver station for permanent receiver station. The people wants to permanently attach to somewhere and get the data and transmit to the internet. And I would like to also hear your challenges and ideas and looking for the collaboration. And you can contact me anytime from Knoedler, and also you can get all the local documentation from the GitHub. Thank you.
Thank you so much for that. I know my family would be really excited about having a GPS tracker for my dog's collar. I think it would be a lot of people peace of mind. I think we just have time for maybe one question. If anybody has one in the chat. But if not, I have a question about if you have any like specific stories or like case studies of how people have used this before that you want to share.
Uh, yeah, people using mostly for the tracking the pets for cats and dogs. And how actually I started to use that when I started to use on my drone. So when I was using in suburban areas, remote areas, there's no network coverages. So other GPS trackers cannot operate there because they use the SIM card and there is no network in the area. And that's how I actually started to develop this GPS tracker.
Amazing. And it looks like we have a few questions for you coming into the chat, so I will send you in there to answer those.